this is a linear regression. So I think linear regression, if you would have had statistics course, so this is something which is always covered, right? So regression is about forming the best fit line or a linear line which tries to minimize the difference between the actual and the predicted, right? So over here, this is just for just a linear regression based approach for seeing how the tip amount varies when uh, on the basis of total bill, right? So yeah, that's about regression. So if I now move on to the other approach, that is the classification approach, right? So in classification, let's say if you're trying to predict whether a person has cancer or not, right? So over here you have a classification model which will generate results in the form of one or two, right? So just if you see 0 and 1, right? So these are the two classes you have, and you have built an entire model which classifies these on the basis of input parameters, right? And this is being used for fraud detection, for detecting whether the news is fake or not. And at the same time, you do get probabilities associated with this, but so the idea is to classify it as 0 or 1 and have it as a categorical variable. And now, clustering is more about trying to identifying or trying to group on the basis of input data points we get. Right. So let's say you are working for a insurance company. So you want to see like, or you're working with a banking company and you want to see that what all customers can be given a credit card, right? So for credit card, I think you need to segment the customers for first, right? So let's say highly profitable and low profitable. So let's say you don't have enough data or enough historical data to see whether the customer was profitable or not, right? So what you'll do is on the basis of yeah. Uh, Pavitra, are you saying anything?
No, sir.
Okay. Oh, okay. I think there was a disturbance. That's it. Cool. So let's say coming back to clustering. So let's say you're working with a banking company and you want to classify customers in the highest profitable and the least profitable. So this is where you didn't know whether previously the customer was profitable or not. So we'll allow the algorithm to do that, right? So over here, on the basis of data points we have, or on the basis of association it has, we'll create a clustering plot, right? So it essentially is dividing our customers on the basis of profitability into two clusters, right? So this is about clustering just to get like just to make aware of people who are not aware of or have undergone courses on machine learning. So these are the basic steps you start up with when you're talking about um, making career in data science, right? And there's another thing like association. So association is heavily used in retail industries. So the idea over here is to see, let's say, if you um, talk about like in Bangalore, there are many hypermarkets, right? So they want to see what kind of association happens between products purchased, right? So over here, let's say a, a person is purchasing tropical food, right? So at the same time, this association chart shows that a person who has purchased tropical food also purchased processed cheese, turkey, grapes, and uh, canned vegetables, right? So this helps the retailers, the merchants to offer promotions. So now what it will do is it will next time create a promotion or discount on tropical fruit since it gets associated with a lot of products, right? Or identify the common points. Let's say if it's a yogurt, so a person who has purchased yogurt was maybe diet conscious, so he did purchase cereals and um, other things, right? So we talk about supervised, we already know what the end outcome was, right? So while I was training the machine learning model, I knew that in future, like in during the test data set, I have this much value, right? This is the actual value, and this is what I've predicted. And on basis of that, I'll be able to identify whether it's right or wrong. And that's how I'll tune my model. So, so regression and classification are two of the major buckets which fall under supervised algorithms. So when we talk about regression, we have linear polynomial regression lines, which I talked about in the previous slide. We have decision trees, which are nothing but just like the one I've created over here, right? So like it's like following a hierarchical structure. Let's say if I have a data set and it needs to create a split, so it will create three splits on the basis of input signal and so on and so forth. So this is what a decision tree does. So there are complex ensemble techniques like random forest and XCB boost, which are based on the fundamental concept of decision tree. Neural networks, as I talked about it, so it's a part of deep learning, right? So that's how it gets fit into regression-based approaches as well. Classification, as mentioned previously, is more about telling zero or one, or having multiple classes is also an issue, is also an option. So yeah. And when we talk about unsupervised algorithms, so in clustering, as I told about, so we weren't aware of the final output. It was more about bucketing the entire data into n number of clusters. So it's also used in anomaly detection, right? So in anomaly detection, it runs through the entire data set and helps in generating a flag whenever the value tends to be anomalous, right? So it is used in fraud detection, in fake news detection, and other things, right? And then as I talked about the association rule, we have a priori algorithms and FP growth algorithms to identify relationships in data. And then we have reinforced algorithms. So they're a bit less talked about because of the complexity it handles. But if you think about a chess game, right? So if you want to train a machine learning model on a chess game, so there's no zero or one associated at each and every step. Your you move with king or queen, right? So it's like it's a semi-supervised algorithm in which you will credit the algorithm as soon as it it generates a positive result, or the probability of winning increases. So in a chess, let's say halfway through, you have increased the probability, right? So the algorithm will get rewarded and will try to mimic those patterns more often rather than decreasing its probability of winning, right? So that's about the basic machine learning techniques we have, right?